All right, ladies and gentlemen, let us begin chapter 7.4, evaluate logarithms and graph logarithmic functions. Just one quick reminder, do not forget that you can go onto Moodle. You need to use your computer if you don't have your own calculator. Okay, just a quick reminder that if you go to Moodle, go to the calculator. Okay, go to grade 11. Go to the Mathematics MCA Sampler, click on Start, and then at the top, there's a calculator that you can use. Okay, do not forget you have that option. Again, that will not work on a phone, either your Chromebook or a computer. All right, so let's get rolling. All right, so the first thing we're going to look at is the following. Y equals 2 to the x power. If you recall, that is an exponential growth because the base, is bigger than 1. All right, I'm going to make a table. I'm going to graph it. Okay, this is x, this is y. All right, so we know that I'm going to start with 0. 2 to the 0 power, so x is 0, is 1. 2 to the first power, again, x is 1. 2 to the first power is 2. Okay, 2 squared is 4. 2 to the third power is 8, and so on. All right, so remember, this one's going to curve up, so I'm going to plot those dots. And don't forget that there's a boundary line. The x-axis is the boundary line, so it's curving this way and getting closer, and then curving up like that. Now, back in chapter 6, we learned how to find the inverse of a function. And if you remember, the reflection line is the line y equals x. So that's the diagonal line up 1 over 1 from corner to corner. Okay, that's our reflection line. Now, if I do the inverse of this, remember when we do the inverse of a table, we just switch x and y. So it'll be 1, 0, 2, 1, 4, 2, and 8, 3. Now when I graph those, that's going to be a reflection of the 2 to the x power. All right, so 1, 0, 2, 1, 4, 2, 8, 3. And so it's going to go like this, and then it's going to curve like this, but it's not going to cross now the y-axis. So you can see that the purple and pink lines are reflections of each other. So that means the pink is an inverse of the purple. So y to the 2x has an inverse. Now, if you also recall from the last chapter, when we found the inverse, we switched x and y. So if I switched and I wrote x equals 2 to the y power, okay, well, y is an exponent, and we have not even come close to seeing anything like that. So we've got something else here. So we're not going to do that. The inverse is going to look like this. It's going to be y equals. Okay, now we're going to write log for logarithm, but we're going to abbreviate log. The base is 2. Again, you can see here the base is 2. But when we write the 2, we write it small and a little bit down from the letter G. So that's base 2. And then the x is normal size like that. So this is the inverse of y equals 2 to the x power. Okay, we're going to learn more about that as we go through this lesson. So just know that when we go from here to here, that's the inverse. Okay, let's look at another one. Anytime I'm going too fast, just pause and rewind. All right, moving on. So now I'm going to do y equals 3 to the x power. Okay, so I'm going to make a table. So 3 to the 0 power is 3. 3 to the first power. Sorry, let me back that up. 3 to the 0 power is 1. Make that correction, please. 3 to the 0 power is 1. 3 to the first power is 3. 3 squared is 9. And then 3 cubed would be 27, but that's not going to fit. All right, I'm going to plot those dots. 0, 1, 2, 9, or 1, 3, 2, 9. And again, it's going to curve towards the x-axis going to the left, but it's not going to cross it, and then it's curving up. Our reflection line is still right here. It's a little bit crooked. Hopefully you do a better job. The inverse would be 1, 0, 3, 1, 2, 9, 27, 3. Okay, so that's what the inverse of the graph looks like. Okay, now writing the inverse, y equals log, the base is 3, so a little 3, and then a normal sized x. That is the inverse of y equals 3 to the x power. Okay, so now we're going to look at something else with this. I am going to give you the logarithmic form, and you're going to rewrite the equation in exponential form. So, for example, okay, I'm going to do 4 examples here. So the first one, let's say we have log base 2, 32, and it equals 5. When we rewrite this, we take the base, which is 2. The exponent is what's behind the equal sign. And then 2 to the 5th equals 32. So the logarithmic form to exponential form looks like that. And if you want, you can think of this. Okay, you could draw like a little line like this with an arrow right there. So you're starting at 2. So 2 to the 5th power equals 32. Oops, and then I forgot to write the 2 on there. So 2 to the 5th power equals 32. Okay, the next one, I'm going to write log base 10, 1 equals 0. So my base is 10, my exponent is 0, and it equals 1. 10 to the first power, 10 to the 0 power is 1. Okay, next one. Log base 9, 9 equals 1. Again, the base is 9 to the first power equals 9. Okay, last one on this. Sometimes you can have fractions. So, for example, log base 1/5, 25 equals -2. When you have fractions, you need to use parentheses. So we're going to say, again, the base is 1/5 to the -2 power equals 25. And if you don't believe it, okay, go to your calculator and I can type this in. 1/5. Whoops, that's not what I wanted. 1/5 to the negative 2 power, and it is 25. Remember the saying, cross the line, change the sign. All right, moving on to the next part. Evaluating logarithms. First example. Sometimes you're going to see just an expression like this, hence the word evaluate, okay, because it's an expression. So it might say log base 381. That's an expression. We want to know what does that expression equal. So when you see something like that, you're going to go ahead and you're going to just put an equals x behind it. And then rewrite it. Okay, like we did on the page before this. We're going to write 3 to the x power equals 81. And hopefully you're familiar enough with your exponent rules to be able to figure that out. If you're not, you're going to have to use your calculator. Okay, so like you think it's 3 to the 3rd. No, that wasn't enough. Okay, is it 3 to the 4th? Yes, it is. All right, so that means when we evaluate that, we find out that it equals 4. Okay, next one. Log base 1/4, 256. So again, that's my expression. So I set my expression to equal to x, and I'm going to rewrite it. Again, use parentheses around fractions. So 1/4 to the x power equals 256. If I recall from what we did on the other page, that's got to be a negative exponent because it's going from a fraction to a very large integer. So it's got to be a negative. So let's see. So again, if I'm not sure, I can type that in, 1/4, and then I can try some negative exponents, okay? And I'm just going to say, okay, -4, and look at that. Okay, so it's the log base 1/4, 256. It turns into -4. So that means x is -4. So you may have negative exponents. Okay, let's look at a couple more. Log base 10, and I'm going to talk about log base 10 in a little bit more detail later. 0.001. Again, I'm going to set that equal to x, and I'm going to rewrite this. So 10 to what power equals the decimal 0.001. Again, you're going from a base that is large to a small number, a decimal. So again, you're going to end up with a negative here again. Okay, and if you go ahead and plug some negative exponents in there, you will find out that it is x equals -3. All right, one more. So let's take log base 64, 2. I'm going to go ahead and set that equal to x. I'm going to rewrite this. 64 to the x power equals 2. Oh, okay, so now I'm going from a large base to some power equals 2. Now, it's not a fraction, so I'm not crossing the line and changing the sign. The sign did not change here, so it's going to be a positive exponent. So sometimes you may have to try different fractions. Okay, so like 64. Okay, let's try the fraction of 1/2. Well, I know that's not going to work. That gives me 8. And it's a 2. So you keep trying different fractions. And so I'll try a 1/4, and I find out that no, that's a decimal, but you'll notice I'm closer to 2. Okay, well, in the end, we end up finding the fraction, whoops, 1/6. Okay, so that means that expression equals 1/6. Remember, 64 can be written 2 times 2 times 2 times 2, 6 of them, and it equals 1 of them. Okay, don't forget that little trick we taught you in chapter 6. All right, moving on. Next, we need to talk about the common log. The common log is base 10. So like log base 10x. On the calculator, there is, right here, a log button. That's for base 10 only. Okay, that is for base 10 only. And if you look at your calculator, it's on the left side, right over here next to the 7. That's your log button, and that's base 10. But you'll notice when I push that button, a base 10 did not show up. So this is what you need to know. When it's a base 10, the 10 is not supposed to be written. Okay? It's implied that it is a 10. So if you just see log with no base, it's base 10. It's implied that it's a base 10. So, for example, if you are asked to find the log of 9, well, that can be done on the calculator. You just go to the calculator and you hit log 9, and it knows that it is log base 10. And yes, that's going to be a decimal, so 0.95424. So again, that's the same as log base 10/9, but again, the 10, it does not need to be written. Okay, one more of these and we shall move on. Log 0.85. Again, I don't see a base, so it's implied that it is a 10. So again, on the calculator, you just type in log 0.85, and we see that it is a negative 0.07058. All right, so that's the common log. That's the common log base 10. Moving on, we've got another special one. It's called the natural log, natural logarithm. On your calculator, it's the ln button. Okay, natural log is the ln button. That button is located right underneath the log button. It's next to the number 4. Okay, see if you hit ln. All right, so let's talk about that. The natural log button goes with lesson 7.3. In lesson 7.3, you learned about E. You learned about the Euler or Euler, depending upon which way you want to say that. So that looks like this. It says log base E, E is the base, x. However, we do not write it that way. When it's a natural log with a base E, it's written just ln x. We do not write it that way. Okay, again, that's with a base E. So, if for some reason you saw something like this, log base E 12, okay, you would rewrite that natural log 12. Again, you don't use the E. So that can be typed into the calculator. So again, back to the calculator, you go to our ln and type in the 12, and we've got the answer, 2.48. Okay, so again, if you for some reason saw log E 0.75, okay, that's natural log 0.75. And go ahead and type that in. So negative 0.288, we'll round it. So again, there are two logs that you can just do real easily on your calculator. That's log base 10, common log, and the natural log, where it would be log base e, but we use ln for natural log. All right, so now knowing some of our inverse properties, we're going to use those properties to do some solving. Okay, here we go. So first we got to see this and how this works. Okay, if I have a big base of 10 and I have an exponent. Now exponents could be logarithms, believe it or not. So if I have a base 10 log 9, what happens here is, remember, if you don't see a number down here, it's implied that it is a 10. So if you have 10 to the power of that, these two things are simply going to cancel each other out. So your answer is whatever number is behind the letter G. It's going to be 9. And that's going to be really important with some of the things we solve later on. Okay? If I had a base 8 and I had log with a base 8 with a 7. Again, the 8, this base and this log base 8, they cancel each other out. They have to be the same number. And so my answer would be 7. Pretty simple. Base 6, log base 6, 5. Okay, again, this is going to cancel out, and my answer is 5. So the general rule here is, if you've got a base, log with a base, same base, x, your answer is whatever that number is behind the letter G. That also works with natural log. For example, if I have an e, that's my base, with an ln, natural log, 3. The e and the natural log cancel each other out, and we're left with 3. So e to the ln 3 equals 3. Okay, one more. If I have e to the ln 4x, you can have variables in there also. Well, the e and the ln cancel each other out, and so our answer is 4x. You got to memorize these things, ladies and gentlemen. Okay, so what we're going to do is we're going to use this information to do some inverse functions. Here we go. So let's say I have the equation y equals, take really good notes on this part, you're going to have this on the test. Okay, well, it's all on the test, but this is usually the more challenging part. Y equals natural log, parentheses, x minus 5. All right, so we're going to find the inverse function. So we're going to use what we learned in chapter 6. Here we go. We're going to switch x and y, just like we did in chapter 6. So I'm going to write x equals natural log, parentheses, y minus 5. The next thing we're going to do is what I just taught you on the previous page. Okay, we're going to use what I taught you on the previous page. We're going to write in exponential form. Okay, so this is a natural logarithm. What cancels with the natural log? I hope you said e. All right, so I'm going to rewrite this. Now remember, what I do to one side of an equation, I do to the other. So I'm going to make a big E, that's my base. This x is going to be the exponent. Okay? Equals a big E, and then the ln, parentheses, y minus 5, that all becomes the exponent. Now, what did I learn on the previous page? I learned that the e and the ln are going to cancel each other out. Okay, so what I'm going to do now is I'm going to solve for y. Okay, so the e and the ln cancel each other out. So now I have e to the x on the left, that didn't go anywhere, equals y minus 5. Woo, that's pretty cool. Now I'm going to get y by itself, so I'm going to add 5 to both sides. Okay, now when I rewrite this, I'm going to start with y. So y equals e to the x power plus 5. So this is the inverse of that. Okay, take good notes on that. Think through it. All right, I'm going to go to another example, next page. Again, you can pause and rewind anytime. All right, let's ignore this graph. In fact, I'm going to get rid of it for the moment. All right, this time I'm going to go y equals log times x plus 4. Now remember, what base is implied here? You don't see the number. Okay, base 10. All right, so the first thing we're going to do, remember, is switch x and y. So x equals log parentheses y plus 4. Look back at the previous page. Okay, now we're going to rewrite this. Okay, we're going to write in exponential form. So the base here, remember, is a 10. Okay, the base is 10. So I'm going to rewrite this. Here we go. I'm going to go 10 to the x power equals 10 to the log times y plus 4. The reason we do that is because now I can get rid of this. That cancels each other out. I'm getting rid of the word log. Okay, so now I have 10 to the x power equals y plus 4. Well, that's easy to solve for. We just subtract 4 from both sides. So my final answer is y equals 10 to the x power minus 4. That is the inverse of the original problem. Okay, so the next thing we need to do is look at how things get changed, okay? Some translating here. So here we go. So some graphing. All right, well, first of all, don't forget the rules that I taught you earlier about how things move left or right, up and down, okay? So first, I'm going to go back to the original problem where we did y equals 2 to the x power. And if you remember, the inverse to that is y equals log base 2x. Okay? And the table for this was 0, 1, 1, 2, 2, 4, and 3, 8. Okay, that was the original problem that we began with when I started showing you what the inverse looks like. Okay, and now this is the inverse. And so the inverse, that's where things are switched, right? It's 1, 0, 2, 1, 4, 2, 8, 3. Okay, now we did, that was, again, the first problem we looked at. Now, I'm going to add stuff to that. So here we go. So now I'm going to do this. I'm going to put log base 2, parentheses. Now I'm going to put an x plus 3 in there. And then behind that, I'm going to put a plus 1. Okay, so if you remember this, we do the opposite. That tells us we are going to move left 3 units. In other words, we're going to subtract 3. This means we're going to move up 1 unit. So if I go to my table and I look at the orange one, okay, you got to look at this one right here, okay? Look at that one. Okay, don't look at the purple one, look at the orange one. So we're looking here, we've got a 1. We're going to move it left 3. So we're subtracting 3. So 1, I'm going to do a little scratch. So 1 take away 3, this is going to be negative 2. Then the next one is 2. 2 take away 3, that's negative 1. 4 take away 3, that's 1. And 8 take away 3, that's 5. So my x values are now negative 2, negative 1, 1, and 5. What's happening to my y values? Okay, I'm going up 1, so I'm adding 1. So I'll just do it right here. I'm adding 1 to each of my y values. So that becomes 1, 2, 3, and 4. Okay, so I'm going to graph this. So negative 2, 1. Negative 1, 2, 1, 3, and 5, 0. 5, 4. So it's going like this. However, we do have an asymptote here, and that's something I didn't talk about earlier. My asymptote is now going to be vertical. Okay, it is now a vertical line. So, and what would that vertical line be? Well, that goes with what's happening right there. It shifted to the left 3 units. So in this situation, that's going to be my boundary line. My boundary line is going to be right here. That's my asymptote at negative 3. Again, that comes from what's going on right there. So that means my line looks like this. I need to continue drawing it. It's going to get closer, but it's not going to cross it. So that's what this graph looks like. We'll do another one just to make sure you get it. Now, since my asymptote, okay, my asymptote is x equals negative 3, that affects the domain. Okay? Now remember, when we did the inverse, we switched x and y. So that actually switches with the domain and range. The domain now here is x is greater than negative 3. So the domain values are limited because of this vertical line right here. So the range actually is now all real numbers. So the domain and range actually swap also. Okay, let's do one more. I'm going to make it easy, and I'm just going to keep the same base. Okay, I'm just going to keep it log base 2. Here we go. All right, except I'm going to need a graph. So I'm going to grab this. There we go. All right, so I'm going to keep it the same, but this time I'm going to go log base 2. So just keeping life simple here, keeping it the same base. Except this time I'm going to go x minus 5 minus 3. Okay, what is that telling me? That tells me I'm going to go right 5 units and down 3. Well, first of all, my vertical is going to be at 5. 1, 2, 3, 4, 5. So my vertical is going to be right here. All right, so going back to my original, y equals log base 2x. Okay, going back to that. Remember, that's 1, 0, 2, 1, 4, 2, 8, 3. So now, based on my new equation, I'm going to add 5 to each of these. So 6, 7, 9, and 13. And I'm going to subtract 3 from each of these. So -3, -2, -1, and 0. All right, I'm going to graph what I know. So 6, -3. 7, -2. 9, -1. So it goes like this, and then it's curving right here and not going beyond that boundary line. Okay, so my asymptote is x equals 5. My range is y is greater than, no, my range is all real numbers. Apologies. And my domain is x is greater than 5. All right, good luck with that, and I will see you later.